Okay, problem number 27. We have two quantities that are being divided by one another. We have the quantity in our numerator, which is 3 over x minus 1 plus 3 over a minus 1, and we're dividing it by the quantity in the denominator. So one thing that I did was first I combined the two fractions in the numerator. The result is seen here, right? The next thing that I did was think of the quantity in the denominator as a fraction, right? A fraction of x minus a over 1. So anytime that you divide by a fraction, you multiply by its reciprocal, right? And that is shown here. A lot of times when I do it, I just say, oh, I have a over b divided by c, and I think of it as a over b times 1 over c. I just think of it as if I have a over b as a single quantity, this is the same thing as a over b times 1 over whatever I have here. Some people like to think of it in the two different ways, as multiplying by the reciprocal or just thinking of it as multiplication by that. Okay, and okay, so I simplify this, right? Combine these together. I factored out a common factor of 3 between the two of them, and then I have this, right? As we stated briefly in number 26, right, my rules are, can I qualify the domain easily? So here I know I can see very clearly that x cannot be equal to 1, otherwise I get division by 0. I can see that a cannot be equal to 1 as well for the same reason, and for the same reason again that x cannot be equal to a. And I see that automatically just by looking. I see my three quantities, and if any one of these three quantities are 0, then I'm dividing by 0. So that helps. You can kind of see that also here, right? Because if x was 0, you would be dividing by 0 here. If x was, if x was 1, you would, or if x was a, you'd be dividing by 0 here. If x was 1, you'd be dividing by 0 here. If a was 1, you'd be dividing by 0 here. But I have one single fractional expression that I can utilize, right? All right, so that's enough of problem number 27. Problem number 28 we are going to skip because we did it in class and I need to rewrite it so that it is a little simpler. So we'll skip right to problem number 29. In problem 29 it says to rationalize the denominator, and we're given square root of t plus 5 over square root of t minus 5. Now when you rationalize the denominator, it means that you should have no square root expressions in the denominator. So to do that, you multiply by its conjugate expression. So we have square root of t minus 5, so we multiply it to square root of t plus 5. So when we do that, we have first outside, inside last, right? So we have square root of t times square root of t, which is square root of t squared, which just gives us t. Our outside is plus 5 times the square root of t. Our inside is minus 5 times the square root of t, so those two terms cancel. And then lastly, we have negative 5 times positive 5, which gives us negative 25. And now we have no square roots left in the denominator. On the top, we just do first outside, inside last, and this is that expression. So that's number 29. Number 30, right? Same thing. We take square root 2 times the square root of x minus square root y, and we multiply it by 2 times the square root of x plus the square root of y. Notice that we have to multiply both the top and the bottom because this expression since the top and bottom are equal, since the numerator and the denominator are equal, it's the same thing as 1. So I haven't changed the expression at all by multiplying the top and bottom by the same thing. Okay, so numbers 31 through 35, we have to find all the real solutions of the equations that are shown. So here we put all the x's onto one side and all the constants onto the other. So we add 5x and add 5x and we add 3 and we add 3. 3. This gives us 9x equals 9, so x equals 1. Next expression, right? We have to divide by 25 and then take the square root. So that gives us x both plus or minus 3 over 5. Put out a little bit more explicitly, we're doing x squared equals 9 over 25. We take the square root, and the square root can be either plus or minus whatever we find in the square root, 9 over 25. And then we are finding the square root of both the top and the bottom, the numerator and the denominator, so that's 3 over 5. In number 33, you could do first outside, inside, last, and then solve it with the quadratic equation, but that would be the long and hard way. Instead, we can square root this expression, which is squared, right, which gives us out x plus 4, whatever's on the inside, right? Square root of 36 is either plus or minus 6, and then we subtract 4, right? So then this is what you would get if you did all that work, but easier. So our first solution is x sub 1 equal to 2. Our second solution is x sub 2 equal to negative 10. So if I put negative 10 or 2 into this expression, I would get out 36. Number 34, one thing that I note in my final solution is that I can't get anything that would do division by 0, so I note automatically that x cannot equal to 2 or negative 2. I also notice that x squared minus 4 is the difference of perfect squares. It's the difference of x squared and 2 squared, right? So therefore it should be equal to x plus 2 times x minus 2. So if I take this, right, and multiply it on both sides of my expression, x plus 2 times x minus 2, right? This is the same thing as that, so it cancels. I have to do the same thing on the other side, so pretend this 34 isn't here, and I would have x plus 2 times x minus 2, and I would multiply that to both expressions in this term, right? And my x plus 2 would cancel out with this, leaving 4 times x minus 2. And the x minus 2 would cancel out in the second term, leaving 4 times x plus 2 equal to 5x minus 6. So simplifying this expression leaves me with 8x, right? Because I have a plus 2 term and a minus 2 term and a plus 2 term here. So the 8 and the negative 8 and the 8 cancel, leaving me with only 8x. And that's equal to 5x minus 6, and then it's just a linear expressions on either side, and I have 13 over 6 as my final solution. Number 35, I thought I didn't give you any tricky ones, but apparently I did. So I have x to a 3/4, and I want to know when that is equal to negative 8. Okay, well, I have a fractional exponent, right? Or rational exponent. I can raise that rational exponent to a power of 4 over 3. The reason that I do that is that a power raised to a power, I multiply the 2, and I just get x to a first when I do that. So anything that I do on the one side, I also have to do on the other side. So, and by the way, the x to the first is what we're looking for, right? X to a first is the same thing as x. So we are looking for whatever x is equal to. That's why we would multiply by the reciprocal in the powers. So I have to find -8 to a 4 over 3. So in the denominator of a root, right, or in the denominator of a rational exponent, it means to find the root of that. So -8 is equal to -2 times -2 times -2. So that is 1. So that is my cube root of -2. So -8 to an nth root, right, is equal to -2. So when I take -2, and then I already found the cube root, so I don't have that division by 3 anymore. When I take -2 and raise it to a 4th power, I get 16. So we would think that 16 would be our final solution. However, 16 to a 3 over 4 is not equal to 8. The 4th root of 16 is positive 2, and 2 cubed is equal to 8, and it's not equal to -8. So I don't think any solutions exist for that. And that's tricky. And I thought I didn't give you any tricky ones, but apparently I did. So we're going to pick back up on number 36 and 37 after when we start again.